So independent meant that there was no effect whatsoever. Dependent, there is an effect. So if you think about the term dependent, right now it's tax season. You know, parents are having to fill out their tax forms, and on it, it says, how many dependents do you claim? Dependents would be their children. How many children are they claiming? The reason that they call children dependents is because you depend on your parent and their choices. So if your parent decides to get a new job that's in Virginia, where do you think you're going? Virginia. Okay, if your parent loses their job, do you think that you're going to be able to buy the shoes that you might want? Probably not. Okay, you depend on the things that happen to your parent. So when things happen to your parent, they are the ultimate independent person. But what happens to them affects you. So their choices, if they decide that they're going to move, you move too. If they decide that they want to quit their job, you are being affected by those choices. When they go grocery shopping, guess what? You're eating what they buy. Okay, so they're making the choices and you're having to basically deal with those choices. That's why it's calling you a dependent person. Okay, it's the same thing when we're talking about events. Dependent events means that the probability of the first event is going to affect the probability that the second event is going to happen. So when I put you guys in order for a seating chart, if I put Sirius here, can I put him anywhere else now? No. Once I've chosen him, I'm no longer allowed to choose him again to place him somewhere else. Okay, I can't duplicate him. So the probability of choosing you for a certain spot changes as I start placing people down. 8 headphones? Check in there. So essentially, yeah, no. Essentially, yesterday I told you guys that independent was taking the probability of event M and multiplying it by the probability of event N. This time with dependent, you start off the same way. You still take that probability of event M. You're still multiplying, but now it's event N after M. So once event M has happened, you now have to remove event M as a possible outcome. It's no longer there to be represented. So the probability of N now changes. So it would be like me saying, I have a bag of marbles. I'm going to take a marble, pull it out of the bag, and then throw it. Do I have that marble in that bag anymore? No, because I just threw it away. So the possibility of getting that same kind of color is now different. So maybe I've got like 5 blues and 2 reds. So if I take out a red and throw it, I no longer have 2 reds anymore. I'm now down to 1 red, which means I've lessened the possibility of getting it. Okay? So the best way that you can think of it when you're talking about dependent, you have to think of the terms no replacement. It's not being replaced, or it's without replacement. That's a key term. If it's no longer being replaced, it's being removed entirely from the situation, that makes it a dependent probability. So let's take a look at a couple of problems. Let's say that we've got a bag of Skittles that you're going to eat. So if you're eating the Skittles, are you putting it back in the bag? No. Once you eat it, that Skittle is gone. So the bag of Skittles that you are eating, and the bag contains 10 red, 8 purple, 12 yellow, 13 orange, and 7 green. So I want to go ahead and I want to find the probability that I'm going to pull out a red Skittle, eat it, and then pull out a yellow Skittle. So I want to pull out a red Skittle first, eat that, and then get a red Skittle first, eat it, get a yellow Skittle second. So the best way that I can tell you guys to work a problem like this out is by creating a map. Like mapping out what stuff do you have. Yeah, turn it off. What stuff do you have and what stuff is remaining after you've removed what you were getting the first time. So we'll call it different rounds. So let's focus on the first round. The first round of us wanting to pick out a red, how many red do we have in the bag?
10.
10. We have 10 reds. Okay, but that's not the only ones that we have. We also have purple. How many purple did we have? 8. Okay, how many yellow did we have? 12. How many orange? Okay, and then how many green? Now, that represents the total number of Skittles that we have in the bag, which is what? How many total Skittles are in that bag? Right, I hate that answer. Don't ever do that again. Don't worry about it. 50, thank you. So we have 50 total Skittles inside that bag. So the probability right now for round 1, because the red is the first round, we're basing everything in my first round for the probability of red. What is the probability that red is going to be chosen? 10 out of 50, right? 10 red Skittles, 50 total Skittles. 10 red, 50 total. Okay, yes. I know, it'll simplify to 1/5, but right now I'm not going to concern about simplifying because you guys can do that by putting it in the calculator and hitting enter. It'll simplify it. All right, so I pulled out a red Skittle. What am I doing with it? I'm eating it. So by the time I go in for my second Skittle, how many red do I have? 9, right? I'm going to take 1 Skittle away, and I'm now going to have 9 of them. I took 1 away, and I'm left with 9. Did I take any purple away? No, because remember, I took a red out. So that means my purple Skittles are still 8. My yellow Skittles are still 12. My orange Skittles are still 13. My green Skittles are still 7. Is my total still 50? No, because I took out a red Skittle. So that means not only is red going to decrease by 1, but the total is going to decrease by 1, and it's now at a 49. Now I can find the probability for my second event, which is the probability of yellow. That's why we said it's event M and then event N after M has been removed. So we took the event M away, and this is what we have remaining. So what's the probability of yellow for our second round? 8 out of, or not 8, no, you're looking at purple. 12 out of 49. And what operation do we do? Multiplication. We're going to multiply those together, not cross multiply. Cross product, you're thinking of proportions. This you just multiply. You do 10 over 50 times 12 over 49. Kimberly, what do we get? Very good. 12 over 245. Remember, the calculator will simplify it for you, so let it do its job. Let's try another one. I want the probability of 2 yellows. The probability that I'm going to get 2 yellows. Okay, so we're going back to the original problem, the original amount in the bag. So I'm starting it all over again. I had my red, I have my purple, my yellow, my orange, my green, and my total. Nothing has changed at this point. For my first round, I have 10 red. I have my 8 purple, my 12 yellow, my 13 green, 13 orange and 7 green for 50 total. So what's the first probability I'm trying to find?
Yellow.
Yellow. How many yellow am I trying to get?
12.
Well, 2 in a row.
Oh, no.
So I'm just picking out one yellow right now. So currently, what's the probability of yellow for that first round? 12 out of 50. 12 out of 50. Now I'm going to go in for the second round. What's going to happen when I go to my second round? What's going to happen, Harmon? What's going to decrease? The total and the yellow. And how much are they going to decrease by? By 1. Give me your phone. It's going to decrease by 1. Okay. All right. So they're going to decrease by 1. So we get 10, 8, 11, 13, 7, and now this becomes 49. Okay, so now second round, we want to find probability of yellow yet again. So based off of the second round, what's the probability that yellow is going to happen here, Harmon? 11 out of 49. Now your calculator is not going to do this one because the denominator is too large, but you would get 66 out of 1,225. I want you guys to try this one on your own. Same situation, same scenario. Bag of Skittles with 50 of them in there. I want you to find the probability that the first Skittle that you'll pull out will be purple, and the second one is going to be a green. So do this one on your own. Yeah, honey. Your calculator is going to do some of that sometimes. So what you can do is you can simplify each of them as much as you possibly can, and then multiply the numerators together, and then multiply the denominators, and do that separately in your calculator. Okay? The multiplication button. Yeah. Yeah, you have to press it real hard, and then it'll get in there. Like, I mean, you really have to not just tap it, you have to push it really hard. All right, so if it's mapped out, again, remember you start from the very beginning. You had 10 red, you had 8 purple, you had 12 yellow, you had 13 of the orange and 7 green for a total of 50. You had a total of 50. So the probability that you're going to get purple right then and there is going to be 8 purple out of 50 total. That's because it's based off of your first round, right? Purple's based off of your first round, 8 over 50. Now, if I take a purple, so I got a purple, I ate the purple, so that means I no longer have 8, I now have 7. That means I no longer have 50 total in the bag, I now have 49. But all the other colors stay the same. I had 10 of my red, I still have 12 of my yellow, I still have 13 of my orange, I still have 7 of my green. Okay, now I want the probability that I'm going to pick out a green one for my second Skittle. So I've got 7 green out of 49, so 7 over 49. Then I multiply them, and that's going to give me the 4 over 175. Okay, now there's a couple other ones that I want to try, so go ahead and turn to page 38, or sorry, 39 in your notebook. So page 39, we're going to try a different problem. Let's say that we're having some fruit. So we've got 3 apples. 4 over 175. We have 3 apples. We've got 2 pears. We've got 5 oranges. Hey, hon. On the desks. That's all I've got. We've got 10 bananas. Make sure you bring it back, please. Okay, so you're going to pick out a piece of fruit, and of course you're going to eat it because we want to make sure that we're doing a dependent situation so that That piece of fruit needs to be gone. If we have a situation where I want you to pick 2 fruit that are not apples, 2 fruit that are not apples. So it's no different. Situation's still going to be exactly the same. You want to map it out. So we started off with 3 apples, 2 pears, 5 oranges, and 10 bananas for a total amount of 20 fruit. So I want the probability that I'm not going to pick an apple. So if I do not want to pick an apple, which fruits does that mean is available? Pears, oranges, and bananas. How many pears, oranges, and bananas do we have? So total, we have 17. We have 17 available pieces of fruit out of the 20 that are not considered to be apple. Now, I need to eat that fruit. So that means I chose one of these fruits, only one of them. Does it matter which one I choose? No. So I'm just going to say I ate a pear. I'm going to take one away from the pear. Where else do I need to take one away from? The total. So I still have 3 apples remaining. I now have 1 pear. I still have 5 oranges. I still have 10 bananas. I now have 19 pieces of fruit. Again, it didn't matter which piece of fruit I removed as long as it was not an apple. I just removed one of them. And now I want the probability of not an apple yet again. So I don't want that apple. So which fruits? 16. I have 16 fruit that are not apple out of 19, not 20. We got rid of one of the fruits. And then you just multiply that. So this is using complements with dependent probability, the non-probability or the not probabilities. That would give you 68 over 95. We'll do one more, and then I want to have you guys being able to work on your own. Yes, go ahead. Okay, I want to pick 2 fruits that are not apples or pears. I don't want apples. I don't want pears. Well, I really want to get you guys going. Okay, so we have 3 apples, 2 pears, 5 oranges, 10 bananas, 20 total pieces of fruit. So I want the probability that it's not apple or pear. So that means what fruits can I choose? Oranges and bananas. How many oranges and bananas are there? 15 out of 20. Does it matter which one I choose? No, I'm going to go with the banana. I'm going to take 1 banana away. I have 9 bananas left. Take 1 away from my total. I have 19 left. I still have 5 oranges. I still have 2 pears. I still have 3 apples. And now, once again, I want the probability of not eating an apple or a pear. So that means I'm focusing on oranges and bananas. How many oranges and bananas are there remaining? 14 out of 19. And then we multiply. We're going to get 21 out of 38. Okay, you guys have an assignment that's going to go into your notebook. Glue it in on page 40. Page 40.